Hello everyone, and I am Sahil Sawant, M.Tech in Computer Engineering at VJTI Mumbai and B.Tech in Electronics and Telecommunication Engineering from VIT Pune. Today, let's understand Newton's laws of motion, the foundation of almost every JEE mechanics problem. Newton's laws explain why objects move, stop, or change their direction. If you master these three laws, you can solve any problem from friction, circular motion, collisions, or even rotation. Now let's break them down one by one. Newton's first law says that a body continues in the state of rest or uniform motion until and unless an external force is applied on it. This resistance to change is called inertia. That's why when a bus suddenly stops, your body moves forward. Your body wants to continue in its state of motion. In JEE, inertia helps you identify whether net force is equal to 0 or not. Moving on to the second law, Newton's second law gives us the most powerful equation in mechanics. Force equals to mass into acceleration. This law tells that force is responsible for change in velocity of an object. More force gives more acceleration, means more mass, and that means more resistance to the motion. Most JEE problems are solved by writing F equals to ma along with each direction. Newton's third law states that for every action there is equal and opposite reaction. These forces act on different bodies, not on the same one. This is why rockets move forward, why you can walk, and why recoil happens in guns. In JEE, never cancel action and reaction forces. They act on different objects. That is to be noted. Before applying any formula, always draw a free body diagram. If your diagram is correct, the solution becomes straightforward. Newton's laws are not about memorizing the formulas. They are about thinking logically. Now, a JEE level question will appear on the screen. Try solving it using Newton's laws and free body diagrams. Write your final answer in the comments and I'll reply with the correct solution by the end of the day. If this helps, like the video, share it with your JEE friends. Follow me on Instagram and subscribe to my YouTube channel for detailed problem solving sessions. Hello and good morning everyone. I am Sahil Sawant and today we are starting with one of the most important chapters in physics, that is kinematics. Kinematics is the study of motion without worrying about the forces causing it. In this chapter we only care about displacement, velocity, acceleration and time, four pillars of kinematics. First, let's talk about the equations of the motion. These equations apply only when acceleration acting on them is constant. The first equation relates velocity and time. The second equation relates displacement and time. And the third directly connects velocity and displacement. Most mistakes in exam happen when students blindly apply this equation without checking whether acceleration is constant or not. Now, let's move on to the projectile motion. Projectile motion looks complicated but is actually very simple. It is just combination of two independent motion, horizontal motion with constant velocity and the vertical motion with constant acceleration due to gravity. This is why always resolve motion into x-axis and y-axis, the two directions, and then apply the equation separately. Time of flight, maximum height and range all come from this basic idea. Next, we come to relative velocity. Relative velocity tells us how fast the object is moving with respect to another. This concept is extremely important in problem solving, like two trains or boats and rivers or Rainman problems and collisions. In exams, kinematics is not just about memorizing the formulas. It's about visualizing the motion and choosing the correct direction, and then selecting the right equation to apply on the problem. Now here is a question for you. Try solving the given question and comment your answer in the comments. If this helped, like this video and share it with your JEE friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanations. Hello everyone and welcome back to my channel. I am Sahil Sawant and today we will be covering work, energy and power, one of the most important chapters for the examination. If you master this chapter, half of mechanics becomes easy. So starting with the first concept, that is work. In physics, work is done only when a force causes a certain amount of displacement. That means if a force is present but no displacement occurs, that means no work is done. Displacement occurs but no force was applied, that also means no amount of work is done. Moving on to the second concept of energy. Energy is simply the capacity of a body to do work. In exam, we as students are mainly asked questions about two types of energy: kinetic energy and potential energy. Kinetic energy is the energy that occurs due to motion, whereas potential energy is the energy that is stored inside the body due to the position or the factor of position. These two, they keep converting themselves into each other time by time. For example, if we press a spring, the energy stored in the spring is about potential energy, but when we release it, the spring just bounces off. That's the conversion of energy from potential energy to the kinetic energy. Now we look up to work energy theorem. It is a powerful idea, and work energy theorem says net work done on a body equals to the change in the kinetic energy of the body. This helps us avoid long force calculations, and instead of tracking each and every force, we just compare initial and final energy levels. When no non-conservative forces like friction are present in the problem, total mechanical energy remains constant. Energy in the fact is never created and neither can be destroyed. It can only change the form from one form to another. This type of principle, the conservation of energy, applies in free fall, inclined planes, springs and roller coaster type problems. Toppers always ask this one question for a hint: can I solve this particular problem using energy instead of force? If the answer is yes, that is the fastest path to solving the problem. Now pause the screen and solve this exam type of question. Comment your answers below and I will pin the correct solution afterwards. If you find this video helpful, like the video, share it with your friends and follow me on Instagram and subscribe to my YouTube channel for full length explanations. Thank you. Hello everyone and welcome back to my channel. I am Sahil Sawant and today we will be understanding rotational motion, one of the most important and feared chapters in examination. If you understand torque, moment of inertia and angular momentum, half the chapter becomes very easy. Now torque is the rotational effect of a force. Just like how force causes linear acceleration, torque causes angular acceleration. Mathematically, torque is defined as tau equals to I alpha, which is the rotational version of F equals ma. Now torque depends on where the force is actually applied and not just how strong the force is applied. That's why while opening a door, we apply the force on the edges and not on the hinge, that is not near the hinge. Moving on to moment of inertia, which tells us how difficult it is for the body to rotate along its axis. It depends on mass distribution and not just the mass. Same object but different axes will have different moments of inertia. In exams, most mistakes happen because students forget about axis of rotation. Now a student must always remember that mass, how much it is far from the axis of rotation, defines how higher the moment of inertia is going to be. Moving on to angular momentum. Angular momentum is the rotational equivalent of linear momentum, and mathematically it is defined as L, which equals to I times omega. If no external torque is acting on the body, angular momentum is always conserved. That is why a spinning skater rotates faster when she pulls her arm inside. Thus the moment of inertia decreases and the angular velocity is going to increase. In examinations, these three concepts always come together. First, identify the torque, then check the moment of inertia, and finally apply the angular momentum conservation if the total torque is 0. Now here is a JEE type of question for you. Solve the question and comment your answer with a proper reasoning. If you found this video helpful, like the video and share it with your JEE friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanation. Until then, we will meet in the next video. Until then, take care and sayonara. Hello everyone and welcome back to my channel. I am Sahil Sawant, and in today's video we are going to understand about gravitation, a chapter that can easily fetch you 2 to 3 direct questions in our examination. So now, have you ever wondered why planets don't fall onto sun and why don't the satellites fall onto Earth? According to the Newton's laws, each and every mass attracts each and other equal mass. The force is directly proportional to the product of masses and is inversely proportional to the square of distances. Mathematically, we represent Newton's law of gravitation as F equals g times of m1 m2 the whole upon r square, where g is the gravitational constant. Now, moving on to the gravitational potential, which tells us how much work is done per unit mass. Now, for a point mass, potential is always going to be negative, which means that the gravity is always attractive in nature, and on the point the gravity due to Earth is been acting. Now, talking about Kepler's laws, Kepler gave us 3 laws to explain planetary motion. The first law stated that planets move in an elliptical orbit and not in the circular orbit that we used to draw in our childhood days. Second one is the planets sweep equal areas in equal amount of time. And last but not the least, importantly, the time period of the satellite is always going to be proportional to the radius of the satellite's cube. That is, t square is directly proportional to cube of r. Now, talking about satellites only, satellites stay in orbit because of the gravitational force which provides the required centripetal force for the satellite. It gives us the most beautiful result, that is, satellite speed depends only on Earth and not on the mass of the satellite that is revolving. Mathematically, V equals to root under gm upon r. Now, pause the video and solve the JEE type of question that is being given below. Comment your answers below and let's see who gets it right. If you found this video helpful, like the video, share it with your friends and follow me on Instagram. Subscribe to my YouTube channel for full length explanations. Until then, we will meet in the next video. Hello and welcome back to another video. I am Sahil Sawant and I am pursuing MTech in Computer Engineering at VJTI Mumbai, and I have completed my BTech in Electronics and Telecommunication Engineering from VIT Pune. Let us understand simple harmonic motion and one of the most important topics of JEE. SHM, which stands for short for simple harmonic motion, appears in mechanics, waves and even AC current. If you understand these 3 equations, displacement, velocity and acceleration, you can solve most of the SHM problems. A body is said to be in simple harmonic motion when the restoring force is directly proportional to the displacement from the mean position, and always it is going to act towards it. Let us look at all these 3 equations, the displacement, velocity and acceleration. So moving first with the displacement equation, the displacement in SHM, simple harmonic motion, is given by x, which equals to a times of sine omega plus phi. Here a is amplitude, omega is the angular frequency and phi is the phase constant of that given position. This equation tells us where the particle is at a given particular moment of time. Moving next with the velocity equation, velocity in SHM, simple harmonic motion, is minimum at mean position and 0 at the extreme positions. Mathematically, when we are writing velocity, velocity is given as v, which equals omega times under the root a square minus x square. This relation is very important for energy based equations which arise in JEE examinations as well. Moving on to the last but not the least equation, that is acceleration equation. Acceleration is the key to identifying the simple harmonic motion. Acceleration is going to be directly proportional to the displacement but opposite in direction. That's why a equals minus omega square x. The negative sign shows the restoring nature of the force. And that's it. Remember, for JEE, displacement defines position, velocity defines energy distribution, and acceleration defines the nature of that particular motion. If acceleration is proportional to minus x, motion is definitely going to be SHM, that is simple harmonic motion. Now pause the video and solve this JEE type question shown on the screen. Drop your answers in the comments. If this helped, like the video, share it with your JEE friends, follow me on Instagram and subscribe to my YouTube channel for full length explanations. Hello everyone and welcome back to the channel. I am Sahil Sawant and in this lecture, let's understand one of the most conceptual topics for JEE physics, that is damped and forced oscillations. If you think oscillations always continue forever, the real life is going to say no. That is where dampening and resonance come in. In real systems, energy is always lost due to friction, air resistance or internal losses. When an oscillating system gradually loses the energy and its amplitude decreases with time, we call it a damped oscillation. The motion still remains oscillatory, but the amplitude keeps on shrinking little by little. This decrease in amplitude is controlled by something we called a dampening factor. Higher the dampening factor means faster the loss of energy. In exam, the students have to remember dampening does not change frequency much for lighting dampening, but it reduces amplitude exponentially. There are three important cases under undamped oscillations. System oscillates with decreasing amplitude. Critical damped oscillations, in which system returns to the equilibrium in minimum time without oscillation. And overdamped oscillations. System returns slowly with no oscillations. Car shock absorbers are designed to be critically damped. Now comes the interesting part, that is the forced oscillations. Here, an external periodic force is continuously applied to the system. Even if dampening is present, the system keeps oscillating because of the energy being supplied from outside. The steady state motion depends only on the driving force and not on the initial conditions. Resonance occurs when the frequency of external forces matches the natural frequency of the system. At resonance, amplitude becomes minimum. In real systems with dampening, resonance frequency is slightly less than the natural frequency. This concept is extremely important from the numericals point of view. The exams usually test resonance curves, bandwidth, energy losses, and reasoning based questions. The one mistake students usually make is to ignore dampening while applying resonance conditions. Now here is a question for you. Solve it and comment your answers below. If this reel has helped you, like the video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanations. Hello everyone and welcome back to my channel. In today's video we are going to start learning about electrostatics. In electrostatics, everything starts with understanding how the charges are going to interact. This interaction is explained using Coulomb's law, and when there are more than two charges involved, we are going to use this principle of superposition. Now let us start by understanding what exactly is Coulomb's law. Coulomb's law tells us that the force between 2 point charges is directly proportional to the product of their charges and is inversely proportional to the distance between them. Mathematically, F equals to K times of Q1 into Q2 upon R square. If the charges are like charges, the force is going to be repulsive force. If the charges are unlike, the force is going to be attractive force. And remember, this force always acts along the line joining the two charges. Now, understanding the superposition principle. Coming to the most important perspective of JEE, that is the superposition. This when the multiple charges are present, the net force on any charge is simply the vector sum of the forces due to each other on the individual charge. Now this literally means you can calculate the force due to the charge at a time and then add them using the vector addition process. Not directly by magnitude, we have to use the vector addition process only. Most JEE questions test our understanding about the direction, symmetry and vector addition and not just the formula. One small sign mistake can change the entire flow of the answer. Now pause the screen and solve this JEE question present on the screen using Coulomb's law and superposition principle. Drop your answers in the comments, like this video, share it with your JEE classmates and follow me on Instagram and subscribe to my YouTube channel for more physics related content. See you in the next one. Good morning and welcome to the video. I am Sahil Sawant and today let's understand one of the most important and confusing topics for aspirants, that is electric field and electric potential. First, let's talk about electric field. Electric field at a particular point tells us the force a charge will experience if placed there. Mathematically, electric field is represented as force per unit charge. For a point charge, the electric field is given by E equals to K times of Q by R square. It depends on the charge value and decreases with the square of distances. The direction of electric field is always from positive charge towards the negative charge. Now consider an electric field, two equal and opposite charges separated by a small distance. The electric field due to the dipole depends on the position and line or equatorial line. This is very important for advanced concepts or the questions related to electric field and potential. Now comes electric potential. Electric potential tells us how much work is done per unit charge to bring a charge from infinity to a particular point. For a point charge, electric potential is represented as V equals K times of Q by R. Notice something important. Potential depends on 1 by R while electric field depended on 1 by R square. Equipotential surfaces are the surfaces where electric potential remains constant. Two key rules that we must remember from examination point of view is that first, electric field is always perpendicular to the equipotential surface, and second, no work is done while moving a charge on equipotential surface. Closer equipotential surfaces means stronger electric field. So remember this, electric field is about the forces while electric potential is about the change in energy. And equipotential surfaces help us visualize these fields. Now here is a JEE type of question for you on the screen. Pause the screen, answer the question and comment your answers below. I'll pin the correct answer to the solution tomorrow. If you find this video helpful, please like it, share it with your JEE friends and follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Hello friends and welcome back to the channel. I am Sahil Sawant and in today's video we are going to talk about Gauss law. Quick note, if this video looks blurry on YouTube, click on the 3 dot options and increase the video quality. If you are watching on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. In this video, we will understand about Gauss law, what electric flux really means and how Gauss law helps us easily calculate electric fields for spheres, cylinders, and we are going to explain all of these things from exam point of view. Electric flux is a measure of how much electric field passes through a surface. Mathematically, flux is given by E dot A, which means only the component of electric field that is perpendicular to the surface contributes. Maximum flux occurs when the field is perpendicular and zero flux occurs when the field is parallel to the surface. Now talking about Gauss law, the Gauss law states that the total electric flux through any closed surface is equal to the net charge enclosed divided by the epsilon naught. Flux equals Q enclosed upon epsilon naught. Very important to note is that only the enclosed charge matters and not the shape of the surface. Let us look at a particular application. Consider a uniformly charged sphere. Outside the sphere, the electric field behaves exactly like a point charge placed at the center. Inside the conducting sphere, electric field is going to be zero. Inside a uniformly charged solid sphere, electric field increases linearly with distance from the center. These three results are extremely important from the exam point of view. Moving at another example, that is of infinite cylinder. Considering an infinitely long charged cylinder, we choose a cylindrical Gaussian surface. Using symmetry, the electric field is same at each and every point on the curved surface. This simplifies the flux calculation and gives the electric field proportional to 1 by R. Now, why is the Gauss law so powerful? Gauss law is powerful because it converts complex vector calculations into simple algebra, but only when the symmetry exists. Now pause the video and solve this exam type of question. Comment your answer below and I'll pin the correct solution to it. If you find this video helpful, like it and share it with your JEE friends. Follow me on Instagram and subscribe to my YouTube channel for full-length physics explanations. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to discuss about capacitors. But before we begin, if you find this video blurry on YouTube, click on the 3 dot option and increase the video quality. If you are watching it on Instagram, you are good to go. Today we are going to understand about capacitors, one of the most important chapters for exam point of view. Capacitors help us store electrical energy and the exams love asking numerical questions on this topic. Follow me on Instagram and subscribe to my YouTube channel for more amazing content on science and engineering field. Now let's begin. A capacitor is a device that stores electric charge and electrical energy. It consists of two conducting plates separated by an insulating material called dielectric. When we connect a battery, a positive charge accumulates on one of the plates and the negative charge starts accumulating on the another plate. The capacitance tells us how much charge a capacitor can store per unit potential difference. And mathematically it is represented as C equals Q upon V. Its SI unit is farad based on Michael Faraday, but in practice we use microfarad or picofarad, that is the lowered versions for farad for real life applications. Now comes one of the most important formula for exams. The energy stored in capacitor is given as U, which equals half of C times V square. This is the energy stored as electric field between the plates and not on the plates. Capacitors can be connected in series or in parallel. In series, the equivalent capacitance decreases, and in parallel, the equivalent capacitance increases. Most exam problems test your understanding on these combinations only. Now it's your turn. An exam type of question will appear on the screen. Try solving it and comment your answer below. I will pin the correct answer later. If this video helped you, like this video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel. Until then, have a good day. Hello everyone and welcome to my another video. I am Sahil Sawant and today we will cover one of the most important and scoring topics for JEE Physics. Ohm's law, Kirchhoff's law and Wheatstone bridge. Let's start simple. Ohm's law states that the current flowing through any conductor is directly proportional to the voltage applied across it as long as temperature is remaining constant. Mathematically, it is represented as V equals to IR. Think of it like voltage is the push, current is the flow and resistance is the opposition to the current that is being flowing. More resistance means less current at the same voltage. Now, JEE does not stop at single resistors. It loves complex circuits. That's where Kirchhoff's law comes in. The first law, called Kirchhoff's current law, states that any junction, the total current entering the circuit equals to the total current leaving the circuit. This is simply conservation of charge. The second law, the Kirchhoff's voltage law, states that in any closed loop, the algebraic sum of all the voltages remains zero. In short, energy is conserved. These two laws together allow us to solve any circuit no matter how complex it is. Now let's talk about the examination favorites, Wheatstone bridge. A Wheatstone bridge is a special resistor network. When the ratio of resistances on one side equals to the ratio of resistances on the another side, the bridge is said to be balanced and no current flows through the middle branch. This single idea can save you approximately 2 to 3 minutes in your examinations if you spot it quickly. Now, here is a question for you. Solve the question given on the screen and comment your answers below. I'll pin the correct solution after 24 hours. If this video really helped you, like it, share it with your friends and follow me on Instagram and subscribe to my YouTube channel for full length explanations. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to discuss the effects of electric current. But before we start, if the video looks blurry, increase the video quality by clicking on the 3-dot option on YouTube. And if you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my channel for amazing science and engineering content. Today we are covering extremely scoring topic for JEE point of view, the heating effect of electric current. This concept explains why electric bulbs glow, heaters work, and why wires get hot when current flows. Questions from this chapter are usually easy numericals and give you a sure shot marks if the concepts are clear. Whenever current flows through a conductor, the electrons collide with atoms of the material. These collisions cause resistance and electrical energy gets converted into heat energy. This phenomenon is the heating effect of electric current. More resistance means more collisions and hence more heat is produced. According to the Joule's law of heating, the heat produced in a conductor depends on three major factors. The first is the square of current, the second is the resistance, and the third, time for which the current flows. And mathematically, the heat produced is given as H equals to I square RT. This formula is extremely important for the exam and the students are supposed to memorize it properly. Now let's talk about power dissipation. Electric power tells us how fast the electrical energy is being converted into heat energy. Power is given by the formula P equals V times I. Using Ohm's law, we can also write it as P equals I square R and P equals V square upon R. These three formulas are frequently used in exams. Heating effect is used in electric heaters, irons, toasters and electric bulbs as well. At the same time, excessive heating can damage circuits, which is why fuses are used to control the flow of current. Now it's your turn. An exam type of question will be displayed on the screen. Solve it using Joule's law or power formulas and comment your answers below. If you like this video, share it with your friends and follow me on Instagram and subscribe to my YouTube channel for full length explanation. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to talk about magnetic effect of electric current. But before we start, if you find this video blurry, on YouTube click on the top right 3 dots option and increase the video quality. If you are watching this on Instagram, you are totally fine. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Today, we are starting with one of the most important chapters of physics, magnetic field due to the current. Specifically, Biot-Savart's law and Ampere's circuit law. If you understand when to use which law, you will solve 80% of the magnetism questions easily. Now, let's start with Biot-Savart's law. It tells us how much magnetic field is produced by a small current element. According to the law, the magnetic field, which is represented as dB, at a point depends on three things. The current I, the length of the current element, that is dl, and the distance r from the element. Mathematically, the magnetic field is directly proportional to L dl sine theta and it is inversely proportional to r square. Direction of magnetic field is given by right hand thumb rule. In exam, we mainly use Biot-Savart's law for magnetic field due to finite wire, magnetic field on axis of a circular loop, and when symmetry is not very simple. Now comes Ampere's circuital law, which is actually a shortcut version. Ampere's law states that the line integral of magnetic field around a closed loop is equal to mu naught times the current enclosed within. It sounds complex, right? But the idea is really very simple. Ampere's law works only when the symmetry is very high. In exam, Ampere's law is used for infinite straight current carrying wire, solenoid and toroid. Here, magnetic field remains constant along the chosen loop, which makes calculations very easy. If the symmetry is perfect, use Ampere's circuital law. If the symmetry is messy, use Biot-Savart's law. Now here is a exam mantra for you guys. Biot-Savart's law is universal, but it is lengthy. Ampere's law is limited but powerful. Exams may mainly test your selection based on this law and not just the calculations. Now pause the video and solve this exam type of question which appears on your screen. Write your full answer in the comments. If the video is helpful for you guys, like it and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanation. Until then, have a good day. Hello friends and welcome to my channel. I am Sahil Sawant, and quick note, if this video looks blurry, click on the 3 dot options on YouTube channel and increase the video quality. If you are watching it on Instagram, you are good to go. In this reel, we will understand force on moving charge and current, including the Lorentz force and cyclotron motion, one of the most important concepts in physics. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Whenever a charged particle moves in a magnetic field, it experiences a force. This simple idea explains electric motors, particle accelerators, and even cosmic rays. Now, let's start with Lorentz force. The total force acting on a charged particle in an electric and magnetic field is called the Lorentz force. Mathematically, it is given by force which equals QE plus Q cross V cross B. Here Q is the amount of charge, E is the electric field, V is the velocity and B is the magnetic field. The magnetic force acts perpendicular to both velocity and magnetic field. Because of this, magnetic force can never change the speed of particle. It can only change its direction. The magnitude of force is QVB sin theta. When velocity is parallel to magnetic field, force is 0. When velocity is perpendicular to the force, the force is going to be maximum. Direction is found using Fleming's left hand rule or even right hand thumb rule. When a charged particle enters a magnetic field perpendicular to its velocity, it moves in a circular path. The magnetic force provides centripetal force. Radius of this circular path is given by mv divided by qv. The principle is used in a device called cyclotron. In a cyclotron, a charged particle gains energy repeatedly by using alternating current field, a constant magnetic field. Cyclotron frequency depends only on charge, magnetic field and mass, but it is not dependent on the velocity. In examinations, questions are asked directly of force, radius of path, time period and cyclotron frequency. If you understand direction and formula logic, the chapter becomes very scoring. Now pause the video and solve this exam type of question shown on the screen. Drop your answers in the comment. If you found this video helpful, share it with your friends, follow me on Instagram and subscribe to my YouTube channel for full length explanations. So hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to learn about electromagnetic induction. Quick note, if this video looks blurry on YouTube, click on the 3 dot options and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering concepts explained with simple terms. Today, we are going to understand one of the most powerful concepts in physics, that is the electromagnetic induction. Electromagnetic induction means producing electricity by using magnetism. Whenever the magnetic flux linked with a circuit changes, an EMF is induced in the circuit. This is the working principle behind generators, transformers, induction cookups and almost entire power systems. Now moving on with the Faraday's law of electromagnetic induction. Faraday's first law states that whenever the magnetic flux linked with a circuit changes, an EMF is induced in the circuit. No change in flux means no induced current. Faraday's second law tells us how much EMF is being produced. The induced EMF is directly proportional to the rate of change of magnetic flux, and mathematically it is represented as E equals minus of d phi by dt. Moving on to the next concept, the most important and confusing part, that is the Lenz's law. Lenz's law says the direction of induced current is such that it opposites the change that causes it. Nature always resists the change. That is why the minus sign exists in Faraday's formula. Now moving on to the next concept of self-inductance. When a changing current in a coil induces EMF in the same coil, we call it self-inductance. This is why current does not change instantly in the inductors. Self-inductance is represented by the letter L, and the formula is given as E equals minus L into dL by dt. When current in one coil induces EMF in the nearby coil, it is called mutual inductance. This is the working principle of the transformers. Now it's your turn. A magnet is moving towards the conducting loop. What will be the direction of induced current in the loop? Clockwise or anti-clockwise? Solve it using Lenz's law and tell me the answers down in the comments. If you find this video helpful, like the video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we will be talking about ray optics. But before we start, if you find this video blurry, click on the 3 dot options on YouTube and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. In this video, we will understand ray optics, one of the most scoring chapters in JEE Physics. We will cover laws of reflection, refraction, and most important, mirror and lens formula that appear every year in the exams. Reflection is when light bounces back after striking a surface. There are 2 laws of reflection. The first law states that the incident ray, the reflected ray, and the normal lie in the same plane. The second law states the angle of incidence is equal to the angle of reflection. These laws are used directly in plane mirrors and spherical mirrors. Moving on to the refraction of light. Refraction is bending of light when it passes from one medium to another due to change in its speed. Snell's law states that sin I by sin R gives us the refractive index. This concept explains why a pencil appears bent in a water and how lenses work. Moving on to the mirror formula. For spherical mirrors, we use mirror formula. 1 upon F equals 1 upon V plus 1 upon U. Here F stands for the focal length, V stands for the image distance, and U stands for the object distance. Always remember to use sign convention properly. This is where students are prone to losing marks. For lens as well, the formula is simple. 1 by F equals 1 by V minus 1 by U. Convex lenses converge the light while concave lenses diverge the light. Ray diagram and formula together make the problem solving very easy. Now here is an exam type of question for you. Solve the following question according to the lens formula and comment your answers below. If you find this video helpful, like it, share it with your friends, and follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Until then, adios. Hello friends and welcome back to my channel again. I am Sahil Sawant and in today's video we are going to talk about wave optics. Quick note, if you find this video blurry on YouTube, click on the 3 dot options and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Today we will understand wave optics, one of the most conceptual and yet scoring topics in physics. Wave optics explains light as a wave and includes three important concepts: Young's double slit experiment, diffraction, and polarization. Let's break them each one by one. First, Young's double slit experiment. When light passes through two very close slits, it doesn't form two bright spots. Instead, it forms alternate bright and dark images. This happens due to interference. Constructive interference gives bright fringes and destructive interference gives dark fringes. The most important formula for examination is about the fringe width, and fringe width beta equals lambda d upon small d. Here lambda is the wavelength, d is the screen's distance from the slits, and small d is the separation of the two slits. Increase the wavelength or screen distance and fringes spread out. Increase the slit separation and fringes come close to each other. Now next is the diffraction. Diffraction occurs when light bends around obstacles or spreads while passing through a narrow slit. Unlike interference, diffraction can occur with a single slit. The central maximum is the brightest and widest. For examinations, remember this condition for minima. A sin theta equals n lambda. As slit width decreases, diffraction is going to increase. Finally, polarization. Polarization proves that the light is a transverse wave. Only transverse waves can be polarized. Longitudinal waves cannot be polarized. Unpolarized light vibrates in all the directions, while polarized light vibrates in only one plane. Malaw's law is important. Intensity equals I naught cos square theta. Now, a JEE type of question will appear on your screen. Pause the video and solve it, and write your answers in the comments below. If this video has helped you, like it and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full-length physics explanation. Until then, adios. Hello friends and welcome back to my channel. I am Sahil Sawant, and in today's reel we are going to talk about photoelectric effect. But before we start, a quick note. If this video looks blurry, click on the three dot options on the top right of YouTube and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Today we are starting with one of the most important chapters of modern physics, that is the photoelectric effect. This single concept connects light, energy, electrons, and even the foundations of quantum physics. And this is a guaranteed scoring topic in many physics examinations. The photoelectric effect is the phenomenon in which electrons are emitted from metal surface when light of sufficient frequency falls on it. Three key observations shocked the scientist. First, no electrons are emitted below a certain frequency, no matter how much intense the light is. Second, electron emission is instantaneous. And the third, increasing the intensity increases the number of electrons, not their energies. Classical physics failed here and Einstein explained it later. Einstein said light comes in packets of energy called photons, and each photon has energy that is given by h nu. The energy is used in two parts. One, to remove the electron from the metal. This is called work function. The second is remaining energy becomes kinetic energy of the electron. So Einstein's photoelectric equation is h nu equals phi plus kinetic energy, that is the maximum kinetic energy of the electron. To measure the maximum kinetic energy, we apply a stopping potential. Stopping potential is the minimum reverse voltage needed to stop the fastest electrons. Mathematically, kinetic energy maximum equals E times of V naught. This is extremely important for the numerical questions. Now, pause this screen and solve the examination type of question that appears on your screen. Drop your answers in the comment and I'll pin the correct answer. If this video has helped you, like it and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we will be talking about atomic structure. But before we begin, a quick note. If you find this video blurry, click on the three dot options on YouTube and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. In this video, we will understand atomic structure using Bohr's model and the hydrogen spectrum, a topic which gives direct questions in examinations. If you understand this properly, modern physics becomes one of the easiest scoring subjects. According to the Bohr's model, electrons revolve around nucleus only, in certain fixed circular orbits called stationary states. Each orbit has a fixed energy, and the electron does not radiate energy while it is revolving. This was Bohr's biggest improvement over classical theory. The energy of the nth orbit is given by E equals to minus 13.6 divided by n square electron volts. So as n increases, energy becomes less negative, meaning the electron is tightly bound. When an electron jumps from a higher orbit to a lower orbit, the energy is released in form of light. This produces the hydrogen spectrum. Different transitions give different spectral series. Lyman series lies in the ultraviolet region. Palmer series lies in the visible region. Paschen series and all the other series lie in the infrared region. The wavelength of emitted light is calculated using Rydberg's formula. JEE mainly tests energy level transitions, spectral series identification and numerical calculations using Bohr's formula. Most questions are direct if your concepts are clear. Now pause the video and solve this examination type of question that is given on the screen. Write your answers in the comment and I will pin the correct solution to it. If you find this video helpful, like the video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full length explanations. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to cover the topic of nuclear physics. But before we begin, a quick note. If you find this video blurry, click on the three dot options on YouTube and increase the video quality. If you are watching on Instagram, you are already good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. And now let's begin. Nuclear physics deals with the study of nucleus, its stability, energy and transformation. This chapter gives direct formula-based questions in the examinations and that's why it is very important and gives high ratings. First concept, that is binding energy. Binding energy is the energy required to completely separate a nucleus into its individual protons and neutrons. More binding energy means more stable nucleus. We calculate the binding energy using Einstein's mass and energy relation, that is E equals mc square. The binding energy per nucleon curve explains why iron is the most stable element in the world. Next is the radioactivity. Radioactivity is the spontaneous decay of an unstable nuclei. There are three main types of radioactive decays. The first is alpha decay, second is beta, and the third is the gamma decay. The key law here is radioactive decay law, which tells us that the decay depends on the number of nuclei, not the external conditions. Half-life and mean life are very important concepts numerically. Now, the most exciting part, that is fission and fusion. Nuclear fission is splitting of a heavy nucleus like uranium and releasing a heavy amount of energy. This principle is used in nuclear reactors. Nuclear fusion, on the other hand, is combining of light nuclei like hydrogen into helium. Fusion powers the sun and releases even more energy than nuclear fission. But it is difficult to attain in a controlled environment. Now, here is an examination type of question for you. Pause the video and think carefully and drop your answers in the comments. If you find this video helpful, like the video and share it with your friends. Follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Until then, have a good day. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to discuss about units and dimensions. Quick note before we start, if you find this video blurry on YouTube, click on the three dot options and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering related content. So let's start with physics with one of the most underrated but high scoring topic: units, dimensions and vectors. This chapter doesn't need heavy formulas, but it can save you marks across mechanics, electricity, thermodynamics and modern physics as well. So let us start with the first thing, that is units and dimensions. Every physical quantity is written as a number multiplied by a unit. For example, velocity is given as meter per second. And dimension tell us the nature of the quantity, like mass, length and time. In exam, dimensional analysis help us in three ways. First is by checking whether a formula is correct or not. Second is by deriving relations between two physical quantities. And third is by eliminating wrong options quickly. Remember, only quantities with the same dimensions can be added or subtracted. Now, let's talk about errors, which many students are going to ignore. Error means uncertainty in the measurement. If you are adding or subtracting quantities, absolute errors are going to be added up. If you are multiplying or dividing the quantities, percentage errors add up. This concept is directly asked in examination questions and is one of the easiest scoring areas. Next is scalars and vectors. The scalar quantities have only magnitude, like mass, time and temperature. Vector quantities on other hand have both magnitude and the direction, like displacement, velocity or force. In examinations, vector addition, resolution and direct logic are extremely important. Scalar product gives a scalar result. Vector product gives a vector result. This idea represents again and again and in mechanics and in magnetism. Now pause the video and look at this JEE type of question on your screen. Try solving it using dimensional analysis and vector concepts. Comment your answers below and I'll reply to the correct solution. If you find this video helpful, like it and share it with your examination friends. Follow me on Instagram and subscribe to my YouTube channel for full-length physics explanations. Until then, goodbye. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to discuss about elasticity. But before we begin, a quick note. If this video is blurry on YouTube, click on the three dot option and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Today we are going to study a very important topic in physics, that is elasticity. This chapter gives direct numericals in examinations and conceptual questions in the examinations as well. Elasticity is property of a material by which it regains its original shape after being deformed or when the force is removed. If the body completely regains the shape, it is called elastic. It shows the plastic behavior. When an external force is applied, internal restoring forces are developed inside the material. Stress is defined as the force applied per unit area. Strain is the fractional change in dimension of the body. Stress is the cause, whereas the strain is the effect of the cause. Now, Young's modulus is defined as the ratio of longitudinal stress to longitudinal strain. It tells us how stiff a material is. Higher Young's modulus means the material is harder to stretch. For example, steel has much higher Young's modulus than rubber. Now, let's understand stress and strain curve. Up to proportional limit, stress is directly proportional to strain. The region obeys Hooke's law. The elastic limit is maximum stress up to which the body can regain its original shape. Beyond this point, permanent deformation will start. This is the plastic behavior. Now, pause the video and solve this examination type of question that is displayed on the screen. Comment your answer below and I will reply and pin the correct solution afterwards. If you find this video helpful, like the video and share it with your JEE friends. Follow me on Instagram and subscribe to my YouTube channel for full-length explanations. Until then, take care. Hello friends and welcome back to my channel. I am Sahil Sawant and in today's video we are going to talk about fluids. But before we begin, a quick note. If you find this video blurry, click on the top 3 dot options on YouTube and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. Today we are covering an extremely important physics topic for JEE, that is fluids. Specifically, Bernoulli's principle, viscosity and surface tension. These concepts explain how liquids and gases, that is the fluids, behave in motion, and they will appear frequently in examinations all over the system. Let's begin with the first topic, that is Bernoulli's principle. It states that for a fluid in steady flow, the sum of pressure energy, kinetic energy and potential energy will remain constant. In simpler words, when final speed increases, pressure decreases. That's why fast moving air above an airplane wing creates lift and why water flows faster through a narrow pipe. For examinations, always remember, high velocity means low pressure. This concept is often tested conceptually in examinations. Next, we will talk about viscosity. Viscosity is the internal resistance offered by fluid to flow. Honey flows slower than water because it has higher viscosity. In examination problems, viscosity explains terminal velocity and motion of objects through fluids. Higher viscosity means more resistance and slower motion. Now, surface tension. It is the tendency of liquid surface to behave like a stretched elastic membrane. That's why water droplets are spherical and insects can walk on water. Surface tension becomes important in capillary rise, bubbles and droplets. And this is very important from numericals point of view. Now here is an examination type of question which is provided below. Solve it using Bernoulli's principle, viscosity or surface tension and comment your answer below. If you find this video helpful, like it, share it with your friends and follow me on Instagram. Subscribe to my YouTube channel for full-length explanation on fluids. Hello friends and welcome back to my YouTube channel. I am Sahil Sawant and in today's video we are going to talk about electromagnetic spectrum. But before we begin, if you find this video blurry, click on the 3 dot options in YouTube and increase the video quality. If you are watching it on Instagram, you are good to go. Follow me on Instagram and subscribe to my YouTube channel for amazing science and engineering content. In this video, we will clearly understand electromagnetic waves, the electromagnetic spectrum and the very important concept of displacement current, a favorite concept for JEE examinations. Electromagnetic waves are waves made of oscillating electric and magnetic fields. They do not need any medium to travel. That's why sunlight reaches Earth through vacuum. The electric field and the magnetic field are perpendicular to each other and are also perpendicular to the direction of propagation of wave. The electromagnetic spectrum is the complete range of electromagnetic waves arranged according to their frequencies or wavelengths. From the lowest frequency to the highest frequency, the order is radio waves, microwaves, infrared, visible light, ultraviolet rays, X-rays and gamma rays. As the frequency increases, the wavelength decreases and the energy also increases. Now comes the most important part, that is the displacement current. Maxwell realized that about the changing electric field can produce a magnetic field even without actual flow of charges. For example, in a charging capacitor, current flows in a wire, but there is no conduction current between the plates. To fix this, Maxwell introduced displacement current, which depends on the rate of change of electric field. This completed Ampere's law and led to the prediction of electromagnetic waves. Because of displacement current and magnetic fields can sustain each other, and that's how electromagnetic waves can travel in the space. Now, an examination type of question will appear on your screen. Solve it and write your answer in the comments. I will reply to the correct answer. If you find this video helpful, share it with your friends and like this video. Follow me on Instagram and subscribe to my YouTube channel for full length explanation.